Drawing a Lewis diagram will assist in determining the electron pair geometry and molecular shape from a given formula. This diagram will help us visualize how the atoms are bonded and if any lone pairs are present. Let's work through an example of CCl4 to help better our understanding. To begin drawing a Lewis diagram, refer to the periodic table of elements to find the number of valence electrons in each atom. The total number of valence electrons in this molecule is 32. 4 electrons from carbon and 7 electrons from each chlorine atom. After drawing the Lewis diagram, count the number of valence electrons in the molecule and compare that value to the calculated number of valence electrons to confirm the correct diagram was drawn. This molecule has 4 electron groups and 4 bonded atoms. Therefore, the electron pair geometry and molecular shape is tetrahedral. Although the diagram portrays the bond angles as 90 degrees, this is not the correct bond angle for this molecule. While Lewis diagrams are helpful tools, they are 2-dimensional representations of a 3-dimensional molecule. Keeping this in mind, the distances between the electron groups are maximized because of their negative charge, which causes the electron groups to repel the other electron groups. This repulsion creates a bond angle of 109.5 degrees. Here is a ball and stick model of CCl4. The electron pair geometry and molecular shape is tetrahedral with 109.5 degree bond angle. Notice that the bonds are located on different planes. Now, let's figure out which types of bonds are present in CCl4. Refer to the periodic table of elements to find the electronegativity value for each atom. Carbon has an electronegativity of 2.4 and chlorine 3.0. Chlorine, being more electronegative, will have a greater attraction for the electrons in the carbon to chlorine bond than carbon. This is shown by chlorine having a partial negative and carbon having a partial positive. Finding the electronegativity difference between the chlorine and carbon will assist in determining which types of bonds are present. When referring back to the possible bond types, this molecule has polar covalent bonds. Although there are polar bonds present, the polarity of this molecule cannot be assumed as polar. To predict molecular polarity, begin by drawing dipole moments for each bond. Dipole moments show the direction of the greatest electron density. Start the arrow at the positive end and draw the point of the arrow towards the negative end of the bond. To determine if this molecule has a net dipole, add the vectors together. Begin by drawing the first vector, paying attention to the length and orientation. Then, continue by drawing the second vector starting from the head of the previous vector. Continue to draw vectors until all are used. If the head of the final vector is located at the tail of the first, then no net dipole moment exists and the molecule is considered nonpolar. Seeing that the bond dipole moments cancel out, CCl4 is nonpolar.